Hello everyone, today we're going to talk about the negation of quantifiers and conditional statements. So let's look at a basic simple definition or concept of what negation means. The negation of a true statement is false, and the negation of a false statement is a true statement. So it's opposite of each other, okay? Now, I'm not saying they're always going to be true, okay? But a simple example, okay, to think of is you can say, today is Monday. And then the negation of that is, today is not Monday. And keyword being not. Okay, so this is the negation right here. Or the statement rather, the negation of the statement is today is not Monday. So it's the opposite, okay? Today is Monday. Let's say today is Monday. It's true, right? And if you negate it, then it would be false, because then you're saying it's not Monday anymore, when in fact it really is, okay? So a true statement becomes false, a false statement becomes true. So that is like the easiest way to kind of, understand that basic concept of negation, okay? What people tend to get more confused is the negation of quantifiers, because there's a specific pattern I'd like you to follow. So I'm going to make a nice little chart on the next slide, and I'm going to show you how to negate quantifiers, okay? Statements that have quantifiers in them. So one thing we're going to look at is, I'm going to make a nice little table, okay? And we're going to use some basic quantifiers, and I want you to use this chart in this very specific order, okay? And what I mean by that is there are 4 quantifiers here in this chart, right? Well, we're going to break them up into 2 pairs, and then each pair, okay, has 2 quantifiers that are going to go together every single time, okay? And the best way to look at that is this, all right? All are basically you could say all are, and the negation of all are would be some are not, and keyword not, okay? And the same goes here, okay? And it does not matter which quantifier you start with. You could start with either one as long as you know it's opposite, all right? It's negation. So that is what I want you to keep in mind, okay? And best thing to do is we can just look at an example, a couple of examples actually. One of them is, you could say some movies are comedies. And that's a true statement. All right? So you notice we're starting off with some. Okay? Some. Okay, some are. Let me just underline that word as well so it matches, okay? Some are. Some movies are comedies. We can agree with that, that's true. And you look at the chart above, okay, the negation of some are would be none are, okay? So you can simply say, none of the movies are comedies, or no movies are comedies. It might be better to say no movies, because we want to imply that none of them are. No movies ever are comedies. We want to make sure that we're saying all movies that exist are not comedies, right? We don't need to be that elaborate in saying that, but we can say it. It's technically a negation, but as long as the word no or none are included in the sentence. So we'll keep it simple and say no movies are comedies. All right? And that becomes a false statement because there are movies that are comedies for sure. We know that. Okay, there are different genres of movies, right? So to say no movies are comedies is a false statement. So we started with a true statement by saying some movies are comedies. We know that's true. And we then negate that and say no movies are comedies. Okay? Or none of the movies are comedies. You may see it worded several different ways. Okay? Which is fine. But this is just one way. So I'm going to write it to match up the chart that I have here so it's easier to follow and understand, and that way you can remember it most likely remember it. Okay? And then another example would be all cars are red. And that is a false statement. Okay? If you want to negate this, then you can say some cars are not red. All right? And that is a true statement. Okay, so all cars are red. We know that's false. Okay, there are many different color vehicles out there. So in order to negate an all quantifier, we have to say some cars are not red, and the key word is not. So I should probably underline these, right? Some are not, right? And then we started off with all are. The negation would be some cars are not red. Okay? So we have to make sure we include that not in there. And it's easy to forget because we can write and just get lost and forget the negative, the negation, but it's important to keep it in there. So use the chart as much as possible to give you a better understanding of negation of basic quantifiers, okay? Okay. The next thing I want to talk about is the difference between a conjunction and a disjunction, so and or. So we want to break that down really briefly, okay? So just a little bit of a mini lesson here with and or, okay? So what this means is this is a conjunction, okay? And the symbol is this caret sign or upside down V, and that would be and. And, no pun intended, and the and the or are frequently confused, and that's understandable because, you know, there are a lot of notation here, and I can see why, and so it's common for people to mix them up. I've seen it happen. I mean, I've done it a few times. It just happens as long as you catch it and go, oh, I realized what I did wrong, and then just correct it. And then once you catch your mistake, you can just fix it. But the upside down V or the caret sign is the and that means conjunction. So a simple example I can write is I like carrots, and I like celery. All right. So what we want to do is we want to make sure that we are breaking it down. I like carrots, okay, is basically going to be your P statement, and your Q statement, whoops, sorry about that. Your Q statement is the other statement to the right of the and, okay? So, and this here is your and symbol. All right, so P and Q, right? Your P is I like carrots and I like celery. Or I like carrots and celery, okay? This is just the formal way of writing it, all right? So if you wanted to do the negation of this statement, okay? Then you have to use the not symbol or the tilde, okay? And so not P and Q. All right, so that is the not symbol that we use, the abbreviation that we use, okay? It's a tilde, but it's called not. So think about the distributive property. You know, we can go ahead and distribute this not over the parentheses. And when you do that, okay, it's logically equivalent to, it actually becomes, you know, not P, and then the and becomes an or, which is a V. And then the Q becomes negative, not Q. Not P is negation, right? Not. All right? And in mathematics, what this reads is, basically reads this. It reads I do not like carrots, or I do not like celery. Okay, that's the formal way of writing it. And don't forget that this is your or, and that's known as a disjunction, okay? So let's make sure we have everything, right? Conjunction, right? The upside down V is and, so P and Q, right? And then the negation of that is not P or not Q. So not meaning I do not like carrots, or I do not like celery. Okay? So that's the difference between a conjunction and a junction. You just have to know the difference between the symbols, okay? So the disjunction, don't forget, is your V, right? And that's or. So the next thing we're going to talk about is, what if we're given a disjunction? Remember, the V is or, right? And that is called a disjunction. Okay? So the negation if you want to take this statement, right, and negate it, we can distribute the not over the parentheses, and we can see that something will occur. Okay, so so the first thing that we want to say is we want to understand that P or Q, okay, means we actually have to give an example because it would make more sense. So let me write that out, okay? Let me go ahead and write this out first. We can say the movie is a comedy or it is a drama. All right, so we're using the word or, okay? Because that's what the V means. The V means or. So P or Q. All right, that's what it means when you have this, P or Q. Okay? Now, if you want to negate it, then this becomes not. When you put the tilde in front of it, it's not P or Q. Okay? So let's make sure that we understand the terminology, all right? So remember that this part of the statement, okay, is your P statement. And then this part of it is your Q. Okay? And then, of course, your or is your word right there. Okay? So that's what it would mean. Okay? And we can basically negate this now, because remember I put the tilde or the not in front of it earlier, right? So let's go ahead and negate it and see what would happen. So let me go ahead and just rewrite it so that we don't get confused, all right? And we can clearly see that if we negate this, okay, we're going to have a little bit of a situation where if we distribute the not sign, we're going to get this. Okay, so let me just rewrite it as this, not P and not Q. So what happens is when we distribute the not, the or, okay, which is the V, changes to and. Okay, changes to and. So remember, this or now becomes and as the only time, because that's logically equivalent. Okay, where the statement becomes not P and not Q. Okay, so we have to distribute that not, and then we can take the same statement we had earlier and just write it. We can say the movie is not a comedy, and it is not a drama. All right? So that's what it would become. All right? That's the negation of a disjunction. Okay? So the next thing I want to show you is a conditional statement. Okay, a conditional statement is, P implies Q, if P then Q. Okay, so basically noted just like this. Okay, the little arrow pointing to the right is imply. So if P implies Q, if P then Q, that is what a conditional statement is. Okay, but just so you understand where it comes from, if you want to negate this conditional statement, okay, so let's say you have P implies Q, right? And you wanted to negate this, okay, that means it's not. Okay, we can say that this statement is logically equivalent. All right. So what is it logically equivalent to? It's equivalent to this. Okay. So we can take the conditional statement, all right, and we can actually distribute the not, just like as we did in algebra, all right, or as you would do in algebra. This is the or, the V is the or, and believe it or not, if you have not P or Q and you negate it, okay, that's the equivalency of the negation of a conditional statement to the left of the of this statement here. So when we distribute that, okay, this is the same thing as saying not P. Okay. So what we want to do is gotta make sure this flips, okay? When we distribute, this actually flips. So that becomes and, okay? And we have to remember that because of the, remember we distribute a not over the parentheses, we have to reverse the or sign, okay? So we just have to remember that. Remember the upside down V is the and. So, and this is logically equivalent to what I just wrote above, okay? Believe it or not, it's logically equivalent, and that's what De Morgan's law is, okay? This is where De Morgan's law comes in, okay? And yet again, that is equivalent to when not is equivalent to just P, okay? And not Q. So you can write this negation of this conditional statement many different ways, and you simplify it, you know, this is the end result right here, okay? This is and, by the way. All right, so we got to make sure it's so easy to lose track or forget to, you know, change the or to and then, you know, vice versa. So that's the only tricky part. You know, this is just the proof of, you know, when you take a conditional statement and negate it, they're logically equivalent to other statements that are the same. And that's what De Morgan's law is, okay? It's just kind of representing something a little differently, all right? So we want to make sure that we understand that, but this is the end result right here, okay? All right, so next, all right. All right, so the next thing I want to clarify is the notations for De Morgan's law. Now, you're going to realize if you were to investigate De Morgan's law, it's written or expressed in many different ways. So the most common ways that I have that can be represented is we're going to let U represent. So let me go ahead and represent or, and that is for union, okay? And the, whoops, I always do this, the upside down U, okay, is going to represent and that's the intersection. It's kind of like when we talk about unions, sets, right? You have sets, okay, which are collections of something in mathematics, and sets can, you know, you can they can have two sets, or you can compare the two sets and see what elements are in common in both sets, and that would be like the intersection, if you will. Okay, and then for this symbol, that's going to represent not. All right. So again, one way for De Morgan's law, you can represent, let's say E is one set and F is another set. Okay, and we want to find the union. Okay, and if we use that symbol, we can say the complement of, the union of set E and set F, right? Well, that is actually equivalent to the complement of E, and that's what that prime is, the intersection of the complement of E and complement of F. Okay? And we can write that as the elements not in E or not in F. And that's equivalent to elements not in E and not in F. So let me make sure I read that right. Okay, the elements not in E or F is equivalent to the elements not in E and not in F. Okay, so we can express it that way as one possibility. Okay, and if I give you this, okay, the complement of the intersection of E and F is equivalent to the union of the complement E and complement F. Okay, so I know the notation is a little bit intense, but you can just express this in many different ways. All right, so that's equivalent to not, the elements not in E and F. Not in E and F, and that's equivalent to the elements not in E or not in F. Okay, so that's one way you could express it using De Morgan's law. If you want to express it using set theory, okay, then the notation is a little different. They use the bar. Okay, so you can say the complement of the union of sets E and F, and you can use the bar over it. Okay, or you can use the bar over just the sets, and that's equivalent to the intersection of the complements of A and B. Okay, so that is one way you can do it. Another way, okay, you have the intersection all right, so that becomes the union of the complements A and B. So the bar means the complement. All right, so let me make sure I have this correct. Okay, that looks good. Okay, double checking here and make sure my notation is right. So the complement of A, we can use the prime. That's also equal to A to the superscript C. That's also the complement. Or you can use A bar. So complement can be expressed using several different symbols. Okay, so we just have to keep that in mind, and that means the complement. All right. So however you want to express this is up to you. They're all correct. It's just what symbols are you used to? A lot of people like, the union and the intersection because they're kind of familiar with that from algebra and college algebra, and it may be more suitable to use that. But you can also use the bars, I'm still using the unions and intersections, but I'm using the bar over it. So that's another possibility that we can do. Okay, another way you can represent this is using formal language. Okay. And I have seen this notation many times. I'm sure some of you have, depending on, what math book or what author writes the math book, what professor, Like I said, the notation's equivalent. It does not matter which one you use, so you just have to pick one that you'd like. Some people prefer to use the gamma symbol. Okay, so it means not, just like the tilde. Okay, so again, the V is or, so if you have P or Q and you want to negate it, okay, then you can do that. And the arrow, the equal sign with the two arrows on both sides, that is a metalogical statement or sign, and it means can be replaced in a logical proof with. So we can just kind of write that. That's metalogical. All right, and that basically means can be replaced in a logical proof with. Okay, a little wordy. That's why we use the symbol metalogical, because we don't want to write that. That's kind of lengthy statement. So, all right. So again, when you choose this notation, it's custom to write the parentheses. Okay. And that's not a 7, that is a gamma. All right. I like using the tilde or the bar or the prime. I like to use the tilde for the negation. It's a little bit easier, but this is another way you can do it. Remember, the upside down V is and, okay? All right. So that's metallogically, means it can be replaced with that. All right. So don't forget, this means not. It's not the number 7. All right. So again, if you have this statement, remember the upside down V is what? And. Okay, so that's metalogical too. Not P or not Q. Does that make sense? And let me write this a little better. I'm sorry about that. All right. So VV is the or. Okay. So pick a notation that you feel comfortable with and go with it, stick with it. If you're going to use one notation, just use it all the time so that you don't get confused. But just be aware, you could take another course, have another professor, read a different math book, same subject, and it could be a different notation. So there's even other types of notation, but I'm not going to get into that right now. But just be aware that it can be represented in several different ways with the notation. I hope that this video helps you, and I hope that it clarifies any questions you may have had with negating a conditional statement and negating quantifiers. Thank you so much for watching.